You know, when you see an AI create some absolutely stunning piece of art or spit out a complex chunk of code in seconds, you kind of have to wonder, is that real creativity? Is the machine actually thinking and imagining like we do, or is it just a really, really clever parrot? To figure that out, we actually need to start with one of the most creative humans who ever lived. Right, Albert Einstein. To get our heads around machine creativity, he's the perfect starting point. Einstein had this idea that creativity wasn't some magical bolt from the blue. He called it combinatory play, just taking ideas you already know and mashing them together in new and surprising ways. This simple idea, it's going to be our lens for looking at the very edge of AI's imagination. So here's how we're going to break this down. First, we'll tackle that big question. Can AI really be creative? Then, we'll dive into a brand new scientific framework designed to measure it. We'll see how they put that framework to the test and unpack the pretty surprising results, including a fundamental trade-off that might change how you think about AI. And finally, we'll tie it all back to the real world and figure out what this ideation gap really means.
Okay, let's jump right into the core of the problem. Today's AIs are getting incredibly good at spitting out ideas, but there's this massive gap between a cool-sounding concept and something that actually works in the real world.
Researchers actually have a name for this. They call it the ideation execution gap. So an AI might dream up some game-changing new drug, but oops, it forgot that the molecule it designed is physically impossible to create. It's got the ideation part down, but the execution part, not so much. And this is a huge roadblock. To get past it, we have to understand where it comes from. So to figure out what's going on, researchers realized they needed a proper way to measure an AI's creative spark, scientifically. So they went ahead and built a whole new framework just for that, to measure a very specific but very important kind of creativity. And that type is combinatorial creativity. See, we're right back to Einstein's combinatory play. The best way to think about it is like a chef. A great chef doesn't invent a new vegetable. They take familiar ingredients, things we all know, and they combine them in a way that creates a dish you've never, ever tasted before. That's combinatorial creativity in a nutshell. And this table here really shows why this kind of creativity is such a unique challenge for AI. Look, a lot of other AI skills are about finding one single correct answer. But combinatorial creativity, or CC, is totally open-ended. The solutions aren't just right or wrong. They exist on this whole spectrum of how new is it and how useful is it. That's what makes it so tough to measure and why a whole new test was needed. So how do you actually test for something like that? Well, to really push these AIs to their creative limits, the researchers designed this incredibly clever experiment. It's kind of like an abstract obstacle course for the AI's brain. Okay, here's how it works in 4 steps. First, they build this massive digital map of interconnected ideas. Second, they train the AI on all the well-known routes, the main highways on the map. Third, and this is the fun part, they give it a creative challenge. Get from point A to point Z, but you have to go through town M, and you are absolutely forbidden from using highway X. And finally, the AI has to come up with a solution, a brand new, valid route that follows all the rules. Now, to score the AI's answers, they needed 2 key metrics. The first one is utility. And for this test, utility is super simple. Did the AI follow the rules? Did it start and end where it was supposed to? Did it hit the required spots and avoid the forbidden ones? If it takes all those boxes, it gets a high utility score. Simple as that. And the second metric is novelty. This is the aha factor. An idea gets a high novelty score if the path it found was long and winding, or if it used some rare backroad connections that no one would have thought of. So a short, obvious route is low novelty. A clever, unexpected shortcut that makes you go, whoa, that's smart. That's high novelty. So they had the test, they had the scoring system, and they ran this thing on tons of different AI models, big and small. And what they found, well, it tells us something really fundamental about how creative today's AI can actually be. First off, they found that the actual shape of the AI model, its architecture, matters a lot. If a model is too shallow and wide, it's like a trivia master who knows one fact about everything but can't connect the dots. It just doesn't have the depth for complex thinking. On the flip side, if it's too deep and narrow, it's like a super specialist who only knows one topic inside and out. It can't make those surprising connections between different fields. So what they discovered was what you could call an architectural Goldilocks zone. To be maximally creative, an AI can't be too wide or too deep. The balance between the breadth of its knowledge and the depth of its reasoning has to be just right. And of course, this leads us to the biggest question in all of AI right now, right? Can we just solve this by throwing more computing power at it? If we just build bigger and bigger and bigger models, will they eventually become these amazing creative geniuses? Well, the answer they found was, pretty stunningly, no. The research uncovered what looks like a fundamental trade-off. As you increase the demand for utility, meaning as you add more rules and more constraints, the novelty of the AI's ideas consistently goes down. The more you force it to be practical and correct, the less creative and surprising it becomes. And let me be really clear about this. This isn't just a problem for the little guys. This novelty-utility trade-off was there across the board. They saw it in models with 1 million parameters, 10 million, and 100 million. Just making the AI bigger does not make this fundamental problem go away. So what does this all mean? How does this abstract finding from a lab test connect to the real world? Well, it turns out it might just be the perfect explanation for that ideation-execution gap we started with. The mapping is almost one-to-one. An exclusion constraint in the test, telling the AI it can't use a certain path, is just like telling an AI in the real world, hey, your idea can't violate the laws of physics. An inclusion constraint is like saying, your new business plan has to account for a budget. The real world is just a creative problem with thousands and thousands of these constraints. And so we get to this powerful conclusion. This novelty-utility trade-off is very likely a root cause of that gap. When we ask an AI to come up with something truly new and groundbreaking, but that also has to obey all the complex rules of reality, physics, budgets, laws, ethics, we're basically forcing it to fight against itself. Its ability to be super novel and super useful at the exact same time seems to be fundamentally limited. And here's another fascinating wrinkle. As the models get bigger, their mistakes don't go away. They just get sneakier. This chart shows that with the biggest models, superficial errors, what we call hallucinations, get less common. But deep logical errors, coming up with an invalid path, become just as frequent. So they might get the surface-level facts right, but their core reasoning can still be completely broken. And that leaves us with this really provocative final thought. If even the most massive AI models we can build are stuck with this fundamental trade-off between being novel and being useful, what does that mean for the future? Maybe it means that AI isn't coming to replace human creativity. Maybe it's destined to be our ultimate creative partner, an incredible engine for generating millions of wild ideas, with a human collaborator always there to do the one thing it can't, bridge that final, crucial gap between a brilliant idea and a practical reality.